All right, Algebra 2. So we are actually skipping ahead a little bit, and we are going to go to 9.1, and this is right triangle trig. And if you kind of ask any math teacher, I bet you that they'll tell you this is one of their favorite topics. It's so much fun. We love working with it. So there's a few things that you, of course, need to know, and we're taking a trip back to geometry for our Pythagorean theorem. There we go, Pythagorean theorem. And you, of course, know that Pythagorean's theorem states that if you have any right triangle that you want, and if you have your legs, that one leg squared plus the other leg squared is equal to your hypotenuse squared. A squared plus B squared equals C squared. If you haven't seen it proved, go ahead, Google it, watch a YouTube video on it. So that's one of the things we're going to use today. The other thing, and hopefully you remember this from geometry, and I'm not going to lie, this is absolutely one of my favorites, are special right triangles. So special right triangles. Now, if you remember, there are two of them, so we need an S there. And if you've already seen this, hopefully this is just a reminder that you have this first one that we work with, which is an isosceles triangle. And if you have an isosceles right triangle, that means that your two angles are 45 degrees because they are congruent. And you would have some sort of side length. And again, the side length would be the same for both of your legs. So using our Pythagorean theorem, we would say that our side length squared plus your other side length squared is equal to your hypotenuse squared. Now we want to figure out what this hypotenuse is. So we're going to solve for it. Let's combine both of those sides. 2s squared is equal to your hypotenuse squared. Okay, my radical geniuses that you are, I know that you know this, that when you take the radical of both sides, that you can go ahead and you can take out the s squared, meaning that s root 2 is equal to your hypotenuse, and we only care about the, oopsies, let's make that an s. We only care about the positive version because it's a length. We don't care about that negative version. So in terms of your special right triangles, you have your 45, 45, 90, or you have a side length and your hypotenuse is that side length root 2. So that's one of them. Your other one is a 30, 60, 90. Let's see if I can kind of get one in here for you. 30, 60, 90. So here's my right triangle. This guy's 60 degrees. This is 30 degrees. And we usually like to start with our short side. So my short side I'm going to label L. And then from here we have that your hypotenuse is 2L and your long leg is short leg times root 3. And if you don't believe me, here we go. We need to prove this. Now, how we're going to prove this is that we're actually starting with a equilateral triangle. Now, my triangle is not equilateral, forgive me, but we'll just pretend that it's equilateral. We'll put these little dashes in here to say, yes, they are. And when we have an equilateral triangle, we know that all of our angles are equal, meaning that they're all 60 degrees. Okay, so what I'm going to do with this equilateral triangle is I'm actually going to go ahead and I'm going to drop an angle bisector down here. And there's that lovely theorem that says that when you drop your angle bisector in a isosceles triangle, it is perpendicular, and it also becomes a segment bisector. Am I throwing you back with all these terms? To your base there. So oops, I'm going to put double hash marks, oopsies, double hash marks in this guy so that we can clarify that the pink guys are congruent down there. Okay, so if this is an angle bisector, we know that it's going to go ahead and it would create half of this, meaning that this new angle is 30 degrees. And if you'll see here is that we've now created a 30, 60, 90 triangle. Now, I'm going to go ahead and I'm going to label this short side L, just like we did in our other one. And because these two are congruent, we know that if I add these up together, I get two of them, so 2L for one big side. Now this is an equilateral triangle, meaning that my hypotenuse is also 2L. Okay, so then my last part is I'm going to have to go ahead and I'm going to have to solve for B. I'm saying, hey, what's that side length over there? So let's use our Pythagorean theorem, meaning that L squared plus B squared is equal to 2L squared. And again, we're solving for this B squared here. So I'm going to go ahead, I'm going to say L squared plus B squared is equal to, I'm going to square the side, 4L squared. Take away L squared from both sides. B squared is equal to 3L squared. And again, you radical geniuses, is that B, or our long side, is equal to your short side times root 3, and you just proved your second special right. So if this is review or if it's not, let's use it right now and let's work through some examples. So example 1, let's draw a triangle here, and it is going to be a 45, 90 triangle on this guy. Now, don't forget that with your 45, 45, 90 triangle, you get to go ahead and declare that it's an isosceles triangle. So I'm labeling some things here, as you can see. One is kind of this, what we call our theta sign. And theta is going to be introduced in terms of our angles. So the first thing I want to know is, what is theta equal to? And you would say, of course, well, theta is equal to 45, because I know that if you have a right triangle and one of the angles are 45, the other one also has to be 45. Let's put some degree markers on there. Okay, then I'm going to go ahead and need to solve for x. So you can either set this up however you'd like, but I know from my special right triangle that if I take x times square root of 2, I'm going to get my hypotenuse, which is 16. Now, you know that you have to divide by root 2. We've worked through this. You're not going to leave a radical in that denominator. Heck no, you're going to rationalize that guy. And when you rationalize this, you get 16 root 2 over 2, meaning that your reduced is 8 root 2. And that is our side length for that 45, 45, 90. Now, of course, we can work through a 30, 60, 90 triangle. Now, one of the things I think I love about these special rights is that you only kind of need like one clue in terms of these, and you can figure out everything else. It's like a one clue puzzle. So here is my special right triangle. And the reason that I know it's special right already is that I have two angles, and one of them's 90, one of them's 60. So I'm asking what theta is. Theta is equal to 30 degrees. You guys know that. Sorry, I keep forgetting my degree markers. Gotta get back on that. Okay, so that's my degree and my angles, but of course, we're gonna wanna know some side lengths. And so I'm gonna go ahead and I'm gonna ask for, I was saying the long side is 6, and the short side is x, the hypotenuse is y. You can set this up however you'd like. You can start solving for some things. Personally, I like to go from my long side to my short side. So I'm going to say x times the square root of 3 is equal to 6. You might have already set this up as x is equal to 6 divided by square root of 3, and you're already starting to rationalize. So x is equal to 6 root 3 over 3. Please simplify. So 2 square root 3. So there's my short side. There's answer number 1. But of course, we need to solve for our hypotenuse, and our hypotenuse is 2 times x, meaning 2 times 2 root 3 is equal to y, meaning that 4 root 3 is equal to y. And we found out everything that we needed to with this triangle. So that's kind of a review in terms of your geometry. And then hopefully a little bit last year, we started talking about trig. So let's switch over to blue because it's kind of a new topic. So this specifically is right triangle trig functions. New functions. We love them. Absolutely. And I'm going to go ahead, I'm going to talk about, maybe you've heard this before, SOHCAHTOA. 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 And do me a favor, look at page, I believe this is 462 in your textbook. Please go ahead and look at that guy. It does a lovely job of drawing a diagram. So there's all these cool functions, and these are the ratios of our right triangles. The ratios of our right triangles. Now, this is just a random right triangle. We don't know what the angle measures are. But I do know that this guy down here is theta. That's what we're going to call theta. I'm going to call this side what's our opposite side of theta, or an O. I'll rewrite that. So we're going to call this O, opposite. Now this is the side next to theta, so it's A, adjacent. And then we always call the side opposite of our right angle our hypotenuse. So we have opposite, adjacent side, and then our hypotenuse. And that leads us into our trig functions. Now the first trig function is sine. Then we also have cosine and tangent. Now, we don't use all of these words. We kind of abbreviate them. I'll write the abbreviation in lighter blue. So for us, we talk about sine as S-I-N, so sine theta. And sine theta is the relationship of your opposite side over your hypotenuse, so O over H. Cosine, also known as COS, is the relationship of your adjacent side to your angle over your hypotenuse. And then your tangent, TAN, of theta is equal to your opposite side over your adjacent. And that leads us back to SOHCAHTOA. So that's how you remember all of those terms. Now, those are just the basic trig functions, but we're actually going to introduce to you the reciprocal of these guys. So the reciprocal of sine is cosecant. So we have cosecant. And when we talk about cosecant, we talk about 1 over sine, and I'll come back to that in just a bit. Where we also have cosine, and the reciprocal of cosine is secant. And then the reciprocal of tangent is cosecant. It's cotangent. I was reading something else. Cotangent. And again, we do not use all of these words. We abbreviate them. So I'm going to switch back to that light blue. So cosecant, we write CSC. So CSC of theta is equal to 1 over sine theta. Now, we know what sine theta is. So actually what happens here is that our cosecant of theta is equal to our hypotenuse over the opposite side. So it actually ends up just the flipping of your sine. So if you have the secant of theta, we know that the secant of theta is 1 over cosine theta, also known as, getting ahead of myself, that the secant of theta is equal to your hypotenuse over your adjacent. Now our cotangent, COT, of theta is equal to 1 over your tangent of theta, also known as cotangent theta, is equal to your adjacent side over your opposite side. Now these are all some great ratios that you need to know absolutely going forward. I'm highlighting all of them so that you know exactly what they are. They are kind of the base of our trig. So using these and using our right triangles, let's again walk through some examples. So we are on example 3. I'm going to go ahead, I'm going to give you a triangle here. See if I can actually do it with the squares. There we go. Okay, so I'm saying that one side of it is 4. I'm saying it's a right triangle, and it's 3 for the other side, and I'm looking at theta here for this angle. So what I'd like you to do is I'd like you to find all of the trig functions. So I'm looking for sine theta, I'm looking for cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. So I want all 6 of them. And in order to figure out all 6, we need to know what the hypotenuse is. Now, maybe you saw already that this is one of those Pythagorean triples, and you can figure it out from there. If you don't believe me, set it up. 4 squared plus 3 squared is equal to your hypotenuse squared, meaning that 25, and we only care about the positive version for this guy. Okay, so now we can go ahead and we can start setting up and figuring out all of these ratios. Okay, so maybe purple for this guy. Sine theta is equal to my opposite, so this opposite side over my hypotenuse. So 4 over 5. I'm gonna go back to this eraser here. Okay. And now my cosine theta is equal to my adjacent side over my hypotenuse. So this guy's equal to 3 over 5. I'm going to erase these little marks. And then my last guy here, my tangent theta is equal to my opposite side, so opposite over my adjacent, 4 over 3. Why did I write 5? 3. There we go. Now, you can figure out the rest of them just from using your other functions, but let's walk through it. So cosecant theta, we're going to go ahead and we are going to take our hypotenuse, so 5 over our opposite, 4. Secant theta is equal to our hypotenuse over our adjacent. And then cotangent, of course, is equal to our adjacent, 3, over our opposite, 4. And just like that, you figured out all of your trig functions. So let's go ahead and let's walk through a few more. Example 4. Now this guy you might have to go ahead and use a calculator for. Here's my triangle. I'm going to say it's a right triangle, but now I'm going to say that this angle down here is 47 degrees. Excuse me. And now I'm going to say that my hypotenuse is 6. And let's find the rest of these guys. So what you can actually do for this is that you can take sine 47, and you can do this in your calculator, but make sure that your calculator is set for degrees, not radians, degrees. All right, so sine 47 is equal to my opposite side, which is A, over my hypotenuse, which is 6. And we can go ahead and we can solve from here. So 6 sine 47 is equal to A.